Hello guys, welcome back to my channel. Today I'm going to be teaching you how to solve equations in limited or restricted domains. Before we get started into some examples, let's look at these symbols for numbers. So when you have to solve an equation in a given domain, sometimes they will, instead of a domain, give you a symbol and you have to know what the symbol means. So the first symbol is this R. It's a fancy R. And that basically means real numbers. Think of R for real. Then we have a fancy Z, and that Z represents integers. To remember it, you can think of integers, we know, are whole numbers and their opposites. And Z is the last letter of the whole alphabet. So you've gone through the whole alphabet when you get to Z, just like how integers are whole numbers and their opposites. So think of the word whole. Next, we have this fancy C, which stands for complex numbers. That's easy to remember because C for complex. Then we have this fancy Q, which represents rational numbers. And the way you can remember that is when you think of rational, another word you can think of is logical. And an IQ test is something that usually tests your logic or your general knowledge. So when you think of this Q, remember rational because of logical, and an IQ test is something that measures that. Then we have N. This stands for natural numbers, and once again that's easy to remember because N for natural. So a limited domain is basically going to define what types of numbers that the solution to your equation can be. So for example, if I'm solving a quadratic equation and I'm given that the answers can only be natural numbers, then I know that whatever solutions I get, they have to be natural numbers. And if they are not, they are something called extraneous. All other solutions that don't fit in that domain are extraneous. And when you think of the word extraneous, think of extra. They are extra solutions that don't fit in the domain. Looking at this example, we have to solve the equation x squared minus 5x is equal to 14. And our domain, which is the limited restricted domain, is natural numbers. So let's go ahead and solve this. So when we're solving a quadratic equation, the first thing we have to do is make the equation equal to 0. So x squared minus 5x, we're going to subtract 14 from both sides, and that way the equation can be equal to 0. So whatever I do on one side, I have to do on the other side. I subtracted 14 from both sides, so now I have x squared minus 5x minus 14 is equal to 0. So now we need to figure out two numbers which will give us a product of negative 14 but a sum of negative 5. So let's start. The easy way to do this is to leave the negatives alone for a second and just think of the numbers. So let's start with 14 and find all the factors of 14. Well, we have 1 and 14 and we have 2 and 7. Those are the factors, right? 1 times 14 is 14, 2 times 7 is 14. Well, I know, if I just think common sense about numbers, that if I do 2 minus 7 or negative 7 plus 2, I'm going to get negative 5. And negative 7 times 2 is also going to give me negative 14. So, to get a product of negative 14 and a sum of negative 5, my two numbers are going to be negative 7 and 2. Now we can factor this out. So we can write x squared plus 2x minus 7x minus 14 is equal to 0. And now we can factor this. If I factor by grouping, so I'm going to take these first two monomials, and I'm going to look at just these two. What can I take out that's common? I can take out an x. So x times x plus 2. And now I'm going to look over here. We're going to take out a negative 7. Right? We can take out a negative 7 from here. And we can take out a negative 7 from here. And when I do that, I'm left with x plus 2. These two parentheses will always come out the same. So, when I did this, whenever you factor out a number, like I was factoring out negative 7, I'm basically dividing it out from both terms. So negative 7 divided by negative 7 leaves me with just x, and negative 14 divided by negative 7 leaves me with just 2. And that's how I got the same parentheses. Because we have the same two parentheses over here, these two terms can come into one parentheses, and this will become the second one. We can also check our work to make sure that we have the correct factored out equation. So if I were to FOIL this back, I have first being x squared, outer plus 2x, inner minus 7x, and last minus 14. This is the same as x squared minus 5x minus 14. And I can see that I got the same equation as I was given, so we factored this out correctly. Now to finish solving the equation, we are going to split this up and make each of these equal to 0. So x minus 7 is equal to 0, and x plus 2 is equal to 0. If I add 7 to both sides, I get that x is equal to 7, and if I subtract 2 from both sides, I get that x is equal to negative 2. So now that we have solved our quadratic equation and got the two answers, or the two solutions, we have to figure out which solution fits in the domain, and then which solution would be extraneous. Now it is possible that all solutions are extraneous, so you have no real solutions, or it could happen so that both of them work and you have no extraneous solutions. So here we know that we have to have natural numbers. And natural numbers, as you remember from the previous video called sets of numbers, which I will link in the description box below, natural numbers are counting numbers. So when we count 1, 2, 3, 4, 5, etc., etc. So when you count, you're not going to include 0 or any of the negative numbers. It's only the whole positive numbers. So our solutions would be 7, because that does come when you count, right? 1, 2, 3, 4, 5, 6, 7. So we would write it as our solution is 7, and you write it in these brackets. And then you can write on the side that x is equal to negative 2 extraneous. So let's go over an example now where we have an absolute value equation. So whenever we're solving absolute value equations, we have to split this up into two different cases. And I'm going to explain why in a second. So case number 1 would be 4x minus 1 is equal to 11. And case number 2 is that 4x minus 1 is equal to negative 11. And so the reason why we do this is because whatever this expression is giving us, we know that an absolute value is always going to be equal to a positive. So if we take this out of the absolute value for a second, and we have 4x minus 1, right? This 4x minus 1 in the absolute value, it could be equal to 11, or it could be equal to negative 11. But when we take the absolute value, you're always going to get positive 11. So we have to account for the fact that without the absolute value, it could be equal to negative 11. This is just giving us 11 that is equal to, because it's still being taken with the absolute value. But when we take it out of the absolute value, we can account that there it could be equal to 11, right? We could take the absolute value of 11 and it would be 11, or we could take the absolute value of negative 11 and get the positive 11. So we have to account for both the positive and the negative. So let's start. So I'm going to just simply solve both sides. Here I'm going to add 1, and I get that. And I get that 4x is equal to 12. Divide both sides by 4. X is equal to 3. Over here, add 1. 4x is equal to negative 10. Divide by 4. X is equal to, now this negative 10/4 can be simplified. We can divide both the numerator and the denominator by 2. So negative 10 divided by 2 is negative 5, and 4 divided by 2 is 2. So we have x is equal to negative 5/2. Our domain is digits, and we know that digits, like a phone number, is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Well, I have a 3 here, so that could count as the solution. So I'd write solution. I'd put it in these brackets. But negative 5/2 is not a digit, right? When you're dialing someone on the phone, you don't dial negative 5/2. So I would write x is equal to negative 5/2 extraneous. And you can abbreviate it like that. Thank you guys so much for watching this video. Tell me in the comments down below if this helped you, or write any more questions you may have. Like, share, comment, and subscribe. I'll see you guys next time. Bye!